Hello and welcome to our Dobot demo. We are Team 1 from Section 8. In Lab 1, we worked on simulating a robot using MATLAB. We had to create all of the rigid bodies and joints of the Dobot given the range of motion. Here is an example of the code creating the bodies and the joints. Here is our final MATLAB model. Still in Lab 1, we began to learn the basic functions of the Dobot magician. First, we learned where the power and reset buttons were located so we could use them appropriately. Then, we learned how to home the Dobot. This means that the robot will go to its home or neutral position. The last thing we did in Lab 1 was learn how to change the end effectors. There were 3 types we used: the suction cup, the pen, and the gripper. Here you can see we are attaching the suction cup, ensuring the vacuum tube is attached and not kinked. Here is the gripper attachment.
Now, talking about Lab 2, we learned how to use different add-ons that were compatible with the Dobot. As you can see in this clip, the IR sensor is recognizing that a block is there, sending a signal to the Dobot to let it know something is there and that it needs to be picked up. We learned how to make feature matches. Here's the screen with the controls needed to perform this task. You can modify many things, but an important one is the region of interest. This is a set area where the Dobot will look for a match. This is an example of a feature match using the Penn State logo. It does not match 100% because the item is not completely in the region of interest. We learned how to find the distance between 2 objects in live action and how to perform a color extraction. You can see here we programmed the Dobot to only recognize blue squares and move them out of the scope. Finally, in Lab 2, we were able to read things using a QR code. This was our generated QR code. In Lab 3, we learned about various ways to communicate with other robots. The main method was using a circuit to send and receive I/O functions. The circuits we built are shown on the following slides here. Here's a demo of how the I/O functions work. One robot picks up the block and places it in the neutral zone. And you can see the blue LED light up, meaning that the signal has been sent to the other robot, notifying to start its goal. Finally, you see the second robot pick up the same block and move it to the end position. The last thing we did in Lab 3 was complete this puzzle. We utilized the shell module block and hard-coded it how we wanted the robot to adjust so the piece could fit into the designated space.
Let's talk about strategy. For the reception, we did 2 color extractions, one for the tan puzzle base and one for the red letters. We adjusted the ROI accordingly so that things would not get mixed up. We told the robot to perform the color extractions first so that it would not get confused with 2 of the same letters but with different colors. Then it would make the match to the letter. After the matches were made, calibration transformations were conducted, and pieces were moved to their respective spots. For the send flow, we used the same strategy regarding color extraction and feature match as mentioned before. We did not utilize the shell module anywhere because we got stuck on it and were taking up valuable time. Overall, we added wait times so that the receiving robot would move once the sending robot was done. No I/O functions were needed because the camera would recognize that letters were in the ROI.
Here is our final demo. As you can see, here we are sending the letters to our partner team. Here we are receiving the letters from our partner team. As you can see, since we did not use a shell module, the letters do not fit exactly into the pan, but they are in the correct location.